Good day, everyone. I'm Rana, and I'm a student in the Polytechnic University of the Philippines, Manila. So in this study, we wanted to quantify the level of light pollution in PAGASA Astronomical Observatory. And before the 2020 Taal eruption, we were able to gather data. So we just resumed our observation a week after the said eruption. So instead of using a sky quality meter, we actually used a DSLR camera. Then we calibrated it before our observation nights. And then we took the pixel value in each data point and converted it into luminance value. So here are the equations that we used. And this shows the timeline of our observation date. And all of our data was gathered every 8 in the evening. So this shows the before the eruption images that we got. And there were nights that it was kind of cloudy. It was very cloudy. And there were also nights that the sky was clear, as well as after the eruption data points. So here shows the luminance value for each data point. And as you can see in the graph, the thicker the clouds were, the higher the value of the luminance. So the average luminance after the eruption was a bit higher compared to before the eruption. And according to the Bortle dark sky scale, both of this luminance level falls under the city scale level 8. So in conclusion, the difference in the luminance value might be associated with the ashes generated by the Taal phreatic eruption, primarily consisting of hydrothermally altered lithic and mineral fragments which were scattered in the air, as well as the cloud formation. So here are all the references in our paper. Thank you.
This presentation reports on the measurement of PM10 and PM2.5 mass concentrations in service laboratories. Particulate matter is categorized into fine particles size 2.5 microns and below, and coarse particles sized between 2.5 and 10 microns. Finer particles penetrate deeper into the respiratory system, increasing risk of health problems. We spend much of our time in indoor spaces where PM concentrations may be greater due to the confined quarters. This study focuses on PM in laboratories where activities include the frequent use of chemicals and the use of electronic equipment, both of which are PM emitting activities. The first site, Lab X, is a digestion lab ventilated by open windows. The second is a food and feeds lab ventilated by air conditioning. Samples were collected using a cascade impactor connected to an air pump. PM-carrying air gets sucked into the device and collected on substrates. Mass concentrations were obtained by gravimetric analysis. The highest PM value occurred when a tour for students was conducted in Lab Y, agitating the PM in the site and suspending them into the air. Another notable result occurred in Lab X days after the 2020 Taal eruption, wherein a spike in PM concentration occurred. In comparison, the days with limited human activity corresponded to two of the lowest obtained mass concentrations. The results were similar for PM2.5, wherein the two highest concentrations occurred on the day of the lab tour and the day after the eruption, and the lowest concentrations occurred during the days of minimal human activity. On average, Lab Y obtained a lower value for mass concentration. Lab X, with a higher concentration, has open window ventilation, which provides means for outdoor PM to infiltrate into the indoors. Both values, however, exceeded the air quality guidelines recommended by the World Health Organization. Thank you very much for listening.
Good day, everyone. I'm Jonna Cristina Larcon, and I'm here to present our study entitled Indoor Air Quality Monitoring System using Arduino Uno in Cainta, Rizal and Pasay City, Philippines, with my co-author Carl Jean Oxina and Erica Castro. According to Environmental Protection Agency, the levels of indoor air pollutions are often 2 to 5 times higher than outdoor levels. Since we spend most of our time indoors, we found it necessary to maintain a good indoor air quality. These parameters are some of the air pollutants that are usually present inside our houses and specifically selected to monitor the air quality system. The device was developed using Arduino Uno and MQ135 gas sensor. The objective of the study is to gather the air quality index in Cainta, Rizal, and Pasay City and compare the data between the two places to know the possible health issues that we can get corresponding to the measurement of the air quality meter. The two area selection is based from the location of the houses that is residential in urban and rural area. The sensor was placed 1 meter above the floor level and observed for 24 hours. These are the detailed sampling parameters for the two areas. Range of ppm gathered in Cainta area reached 30 to 211 ppm. It reached the maximum of 201 in a short period of time, caused by applying an air freshener within the area. Moreover, the air quality stays in average level within the 24 hours and still in good condition based on the air quality index. The results in Pasay City range from 29 to 49 ppm, which shows good level of air quality. Data shown in Figure 3B, indoor air quality in Pasay in midnight has 34 ppm lower area quality compared to Cainta, which has 60 ppm. For the conclusion, both data gathered in Cainta, Rizal, and Pasay City shows good air quality, and healthy levels was detected by sudden exposure and chemical parameters near the sensor. Hence, the increase of concentration of parameters can be stabilized by increasing the ventilation inside the room, like the use of exhaust fans, ceiling fans that could increase the exchange of indoor air from outdoor.
I'm here to discuss our study. Prediction of agricultural drought using Landsat rate, land surface temperature, and normalized difference vegetation index in West Candaba, Pampanga, Philippines. Drought is a natural disaster in Philippines which affects agriculture. The study will show if remote sensing can be used to forecast droughts to help farmers. The study aims to evaluate Landsat TRS to the in situ observation and prediction of agricultural drought over West Candaba, using the 2014 to 2018 March and April, with up to 50% cloud cover representing the dry season. For our results, satellite measurements increases consistently with ground observation, taken on the same day and hour, in good agreement of our value of 0.97. Pampanga River has negative NDVI value and it suggests agricultural field with nearby body of water can easily monitored. There is a thermal changes where LST increases in month of April more than month of March. A negative correlation means that higher vegetation have lower land surface temperature and vice versa. The outside dataset of year 2019 in months of March and April will use for prediction accuracy. NDVI values increase from growing season and decrease during harvesting season. Changes is due to agricultural activities. The computed NDVI minimum, average, and maximum regression equation for March and April, and the derived NDVI minimum, average, and maximum for March and April with a value of forecast bias as shown in the slide. In conclusion, there's a consistency between ground and satellite data. NDVI and LST for 5-year period shows changes caused by agricultural activities. It can be concluded that NDVI is capable of providing forecasts for drought using long-term period of data that could aid timely decision in response to drought. The conclusion drawn are only valid for the time period of the study. Further verification is needed. And this is our references. Thank you very much.
What we don't like about coherent light sources such as lasers is that they have a high degree of temporal coherence, which brings in significant speckle in the produced interference pattern, defeating our purpose for imaging and profilometry applications. So instead of using coherent one, what if we try to employ an incoherent light source, the one who not only has a low temporal, but with a controllable spatial coherence? And what if I say that the answer to this problem only lies in your closet? Here, we will show you how we control the quality of the interference patterns produced using a cost-effective off-the-shelf red LED. To devise how in controlling the spatial coherence of the LED, we first revise the classical method with a digital micromirror device, or a DMD, and a variable pinhole. The DMD is connected to computer to dynamically change the separation distance of the double slits drawn therein. Our method alleviates the difficulties associated with the mechanical arrangements of slits used previously. We can extract theoretically the magnitude of the spatial coherence using the following equation. Fringe visibility and contrast can be used to determine mu experimentally based on the intensity distribution of interference patterns. Results then show that by changing the emitting size of the cores using a variable pinhole and the double slit separation of the dynamic slits realized with DMD, we can control the spatial coherence of an off-the-shelf red LED. Note also that the theory fits the experimental data nicely for all cases. So it is a surprise for us that even with this type of LEDs, one can make desirable interferograms that can be tailored for applications beyond lighting decorations. To know more about our study, scan the QR code below.
When we see with our eyes, the distance which objects are located determines the amount of details which we are able to perceive. This is true even with advanced imaging techniques such as face retrieval. This study is entitled Sampling Volume Considerations for Amplitude Diffuser-based Face Retrieval Method. Variation between intensity measurements is important in multiple plane face retrieval techniques. This variation facilitates the reconstruction of the wavefront face as it contains information about the wavefront behavior. Smooth wavefronts, however, lack this diversity, and thus diffusers are used to introduce intensity variation to these types of wavefronts. Thus, we ask the question, what is the effect of the choice of where we take our intensity measurements on the wavefront reconstruction? Even with diffusers, especially amplitude diffusers, the intensity variation decreases with distance as the high-frequency signal gets scattered away. What's left is the low-frequency signal, which has low intensity variation. Three regions along the eggshell plane are considered. If we use intensity measurements further away from the object plane, the face retrieval algorithm fails to reconstruct the incoming wavefront face. On the other hand, intensity measurements near the object plane provides enough information for a good face reconstruction. This information can then be used in applications, including optical characterization of technical surfaces. For more information, please refer to our paper using the code as shown.
Hello, I am Jason Cabanilla and welcome to this presentation. Have you ever wondered if there is a way that we can obtain 3D surface profile from a 2D captured image? Now if there is a way to do that, can we extend it in profiling small distortions on a flat surface? Well, let's try to find out. I, together with Damien Estacio and Nathaniel Hermosa, present our work Fourier transform profilometry of millimeter scale surface distortions with added lens setup. Actually, there's a lot of techniques that we can use to get a 3D profile from a 2D image. One of them is the Fourier transform profilometry, or simply FTP. FTP is a method that illuminates surface using structured fringe patterns. Here, we only need to have a camera, projector, and a measuring plane. Now, how does FTP works? First, a fringe pattern is displayed onto the measuring plane using a projector. If there is an object on the measuring plane, the fringe is deformed, which induces a face that contains surface height information. With the camera, the 2D image of the illuminated surface is captured. Using Fourier transform, the captured image is transformed to its frequency domain. The first order frequency is filtered, then transform it back to spatial domain. The face is then extracted and the corresponding 3D profile can now be reconstructed. So how can we employ FTP to measure small distortions? We propose a modified FTP setup where a lens is added between the projector and the measuring plane. With this, we can focus the fringe pattern onto the measuring plane, minimizing the effects of the diverging light coming from the projector. Also with the lens, the projected pattern has a relatively higher frequency compared to a non-lens setup. This conserves the sharpness of the displayed pattern. We tested our setup in reconstructing surface of a distorted canvas. These distortions range from 2 to 12 millimeters, and as shown in the figures, we effectively reconstructed 3D profiles of the canvas with millimeter scale distortions with our added lens setup. Questions? Feel free to approach us or scan the QR code below for the full details of our work. Again, I am Jason Cabanella. Thank you for listening.
In simulating femtosecond laser pulses, we always represent the pulse shape to be a Gaussian function, be it spatially or temporally. However, data from experiments show that it is not perfectly Gaussian in shape. In fact, fitting of this data with a Gaussian spectral function of desired pulse width will produce low goodness of fit because some of the pulse peaks will not be accounted. These small inaccuracies can have unfavorable effects in experiments that depend on numerical simulations, so a more accurate depiction of the nature of laser is very important. Hi, I'm Jenny Sagisi from Luman, and in this video we will be looking at temporal laser source term from experimental data to be used in laser matter interaction simulations. We propose a multi-Gaussian fitting to the laser spectra so that smaller peaks will be accounted and RMSE will be improved. Given the spectral signal of a laser pulse f omega, commonly denoted as a Gaussian function, we can obtain the temporal counterpart through its inverse Fourier transform. Here, we want to make f omega as accurate as possible, and to do this, we will add terms to our Gaussian function. In our sample experimental data, as many as 11 terms yielded the lowest RMSE. And after performing IFFT with these 11 Gaussian terms, we get this very nice temporal profile. We want to know then, will this affect our laser matter interaction simulations? So we compared the obtained temporal profile with 100 femtosecond Gaussian pulse duration by calculating the electron and lattice temperatures of a copper film after it is heated by the laser through the well-known two-temperature model. It turns out that multi-term Gaussian pulse gave lower temperatures compared to a pure Gaussian pulse. As we are currently working on the effect of modifying the laser source term in pulse laser ablation simulations, getting the spectral data, which can be easily acquired from the laser itself, should be considered. For questions and clarifications, you can email me at the address shown here. And thank you for your attention.